Algebra 2, this is chapter 1's vocabulary for just section 1. There is a lot of words in section 1. Most of them you know. So an ordered pair is a set of two numbers that represents the x and y coordinates of a point. So if I have 3, 6, that would be an ordered pair. The 3 is the x coordinate and the 6 is the y coordinate. And this little creature down here is called a Cartesian coordinate plane. Sometimes you just hear it called the coordinate plane. Its full name is Cartesian coordinate plane. And if I wanted to plot my little point down there, so let me get a point. There we go, a point. And I want to put this point at 3, 6. I would go 3 in the x direction, 1, 2, 3, and 6 in the y direction. So 1, 2, 3, 4, 5, 6. It would be up there. If I want to change this maybe to a 2, so it might work better, that would be 3, 2 would be right here. And if I want to deal with negatives, I could do the point -2, 1. And let's make that one. Maybe green. And make that point green. Now they kind of go together. So -2, +1 would be -2 in the x direction, +1 in the y direction. Okay, next vocabulary words. By the way, if you want to pause these videos and write these down, you can do that. Quadrants. Quadrants is the next word. We have 4 quadrants. They start with our positive. Positive is quadrant 1 and go counterclockwise around here. So 1, 2, 3, and 4. They are always written in Roman numerals for some reason. But this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. The origin is the point 0, 0. A relation, any set of ordered pairs is a relation. So if you had, and we use these fancy braces, they are called braces. And then you have a parenthesis 2, 3, and then 4, -1. Oops, I put the wrong one there. That one. And then maybe 0, 1. And we'll give one more just for the fun of it. How about 1, -9. Okay. That would be a relation. It's a set of points. Any relation is a set of points. Okay, domain. Domain is the first coordinates. So our domain, and we always write them with braces around them. So our domain is our first points. So this is a first coordinate, this is a first coordinate, first coordinate, first coordinate. They are also the x coordinates. And so our domain here is 2, 4, 0, 1. But we normally write them in order from smallest to greatest. So this 2 actually belongs over here. And this 4 actually belongs over there. Oops, not outside. Put it back in where it belongs. And clean that up. Okay, so that is my domain. It's the x coordinates. And the range is a set of y coordinates. So if I grab a different color here, the y coordinates is 3, 1, -1, 9. And I can do the same thing. Again, I would want to put them in order from least to greatest. So the smallest one of those green numbers is a -9. Then the next smaller is -1. The next smaller is 1, and finally 3. So that is how you would write the domain, which is all of the y's. Okay, domain is all the y's. Hold on a second. Okay, I want to grab some more examples for domain and range. So I'm going to grab with red. Domain is all the x values. So this isn't on my x-axis. So if I follow this up here, and I follow this one up here, this is my lowest point in the x direction and my biggest point in my x direction. And you can see that I have points all along here, right, in both the top and the bottom. So all of these points here are, in fact, part of my domain. So my domain is going to go from 0, 1, 2, 3, 4, 5, down to negative 5. So my domain, I would write this as all of the x's such that negative 5 is my lowest number and 0 is my biggest number. Then I could do my range. Do the same thing. I'll bring my y across. So this is the top of my y. That's the bottom of my y. And I do go everywhere in between there. Right? So this is a negative 2, 3, 4, 5, 6. That's a negative 6. And so my range for this one would be all of the y values such that negative 6 is the lowest one, and negative 2 is my biggest one. So this says x has to be between negative 5 and 0. This says y has to be between negative 6 and negative 2. And if you look at the graph and follow the blue and the red across, that should make some sense, hopefully. Let's do the one that's just points. Let's go grab my domain first. So the domain is straight down, straight down, straight down, straight down, there, and straight up. So this is 0, negative 1, negative 2, negative 3, and this one's 1, and that's 2. And we were not any of the points in between, so in this case, my domain would be negative 3, negative 2, negative 1, 0, 1, 2. Okay? It's just a set of points, so we just have individual numbers. Here it's solid, the line is filled in, there is no point, there's fractions and fractions of fractions. Okay, and then on this one, our range, do the same thing. Range, so if I follow this across, that's a 1, 2, 3, 4, that's a 4, 3, 2, 1, 0, negative 1. So I am going to list lowest as biggest, so it's negative 1, 0, 1, 2, 3, and 4. Okay, so the range is what the y can be, and you can just follow across the y coordinate. And if you look at this point right here, its x coordinate is negative 3, and its y coordinate is 4. And so you should find negative 3 is up here, and 4 is down here. Okay, let's do one more. Again, let's go in the x direction first. You can see it comes straight up, and this line means it goes on forever. So on my x, I have negative 1, negative 2. So I'm starting at negative 2. So my domain is going to be, I didn't leave myself much room here, all x's. Now I can't list every one because we've got fractions again. So I've got to do the such that thing. X has to be greater than or equal to negative 2. Again, you know that it's greater than or equal to because we've got the arrow right here that's pointing forever. And then the range here, if you follow this across, they only touch right here. This is the only place where we touch the y-axis. If you push this line in and push this line in, we just touch here at negative 1. So my range is just negative 1. It's the only value in the y direction where my graph actually exists. So hopefully that's a better description on graphs and domain and range. So we get to function. A relation is a function where for any x, you only have one y. That's what all of that says. It's a lot more words. I gave you the book words here, but that's what it means. Okay, so for every x, you can only have one y. Let's see, my mapping here. I kind of messed this up. There we go. My mapping helps me show a function. So 5 only goes to one number, 6 only goes to one number, 7 only goes to one number, and 8 only goes to one number. Therefore, this is a function. If I had a second line coming off from any of these, so let me grab another line, and we'll make it that lime green. So if I had another one coming off from the 8 up to the 1, 8 would be my x and it's going to 2 different values. That would not be a function anymore. Okay, and then if you look at these points over here, this actually is a 5 pointing to a 2, so it's 0.52. This is a 6 pointing to a 4, so it's 0.64. This is a 7 pointing to a 1, so it's 0.71, and that's how you read the points off of a mapping like this. And 1 to 1 means that every y only has one x to it. So if I had, let's see, another number, say a number 9 down here. Let's put a 9 down here. Okay, and I add another line, and I go from my 4 back to my 9. Okay, so 9 only goes to one number, 8 goes to one number, 7 goes to one number, 6 goes to one number, 5 goes to one number. So it is a function, but on this side, we've got 4 going to 2 different numbers, so it's not 1 to 1. So that's kind of the piece on 1 to 1, is one x can only have one y, and one y can only have one x for 1 to 1. But in a function, we're only looking at the x side, and does each number on this x side only go to one number on the y side. Then we get discrete and continuous. So a graph, that goes back to here, and let's clean this one up again. This graph here is considered discrete because it's got individual points. Okay, anytime you've got to lift your pencil to get to the next point, it is considered to be discrete. So a relation in which the domain is a set of individual points. You have to lift your pencil in order to graph a discrete graph. Continuous is a smooth curve or a line. You never lift your pencil in order to do a continuous graph. So if I go back up to here, this hexagon is a continuous, this ray is continuous. So discrete, individual points, don't lift your pencil, that would be continuous. Discrete, continuous. And then the vertical line test to know if it's a function or not. So if I draw a vertical line, if it's a function, I only touch one point. So right there I only touch one point, but over here I touch 2 points, so this is not a function. On this one, there's no place where I can touch more than 1 point. The arrow doesn't count. The arrow just means I'm going on forever. So this is a function. And down here, at each individual point, there's none right on top of each other. So this is also a function. So this one's not a function. The vertical line touches 2 points right here and right here. If I move it over, it still touches 2 points right here and right there. This one is a function. It only ever touches 1 point. This one is a function, only ever touches 1 point. So vertical line test and function. And then we get to independent and dependent, and hopefully from science class you've got this. Whatever you put on the x-axis is considered to be your independent variable. Whatever you put on your y-axis is supposed to be your dependent variable. So your age versus your height would depend on your age. Your height would be dependent, your age would be independent on the x-axis. 99% of the time, when you talk about any kind of time, time is independent. Time doesn't depend on anything else. Everything depends on time. And then functional notation, instead of using y equals mx plus b, we're going to change out y, and we're now going to use f of x. That's how we read this, f of x. So it's a function in terms of x. So we have an x as a variable over here. If it was f of, let's see, if I just grab this and say f of y, then we would say 2y plus 1. If we wanted g of q, or sorry, it still has to be f because it's still our f function, then we would say 2q plus 1. So that's just telling us what letter we're using it in terms of, and then there's our equation. It's the same equation. We're multiplying 2 times some number plus 1. And then you can fill in numbers here too. So this could be f of 2, and you would say this is 2 times 2 plus 1, and so that would be 4 plus 1, which is equal to 5. And you could actually get a value for that. So that's how we're going to use function notation. And those are your vocabulary words for this section. Again, there's a lot of them.